All right. Hi, everyone. Um, Welcome to our first lecture of ordinary differential equations. So, obviously, this is not the first lecture, sadly. However, I thought that it wasn't going in order, and I decided I'm just going to do it again, all over again. This time, I'm just going to do it properly with, good recording and explanation and stuff like that. I also realized that it wasn't in order. I realized that the way I was explaining was not in order. So the way I was explaining was not in order, which made it very difficult for anyone else to understand. So if you are willing to, you know, understand what happened, if you're willing to learn, and if you have already done the previous lectures and stuff, that's completely fine. You can, continue with that. Uh, but at the same time, I thought that I'm just going to do it all over again. Anyways, so let's begin with our allegedly first lecture, which will be, oh shit, my bad, which will be on, where's the book? So we're gonna focus on the definitions and terminologies, right? But instead of going through the, okay, this is that, we're gonna do one whole question. I'm going to explain the master question thoroughly. And what we're going to do is we're going to do one master question explaining every single thing. So, master example. So let's consider we have an equation. We have dy by dx is equal to y 1 minus y. And we have an implicit solution where I'm going to explain what these are. Don't worry about it. Do not worry about it. Ln of, oh God. We have, can you hear me? Yeah. So we have ln of y by 1 minus y is equal to x plus c. We're going to explain all of it. And we have an initial condition y of 0 is equal to half. So let's begin. Now, step 1. Now, you have done calculus 1 and 2. So you may encounter, so you may have encountered in this equation here. So you do know what this equation is specifically, right? But for whoever who doesn't know what this equation is, this is what you call the first order derivative. This is a differentiation equation, right? This is a first order differentiation equation. And obviously, if I have d square y by dx squared, that's the second order. D third, d to the power 3y by dx cubed, that's third power, and so on and so forth. And so we're going to have dy to d to the power ny divided by dx to the power n. Cool. So this is the first order differential equation. And obviously the highest order derivative is 1. So we're going to, this is the highest order derivative, highest order derivative is 1 here. So now let's expand it. So step 2, we are going to expand it. So I have dy by dx is equal to y minus y square, or dy by dx minus y plus y square is equal to 0. And so now we have what we call y square. We have already encountered what the highest order derivative is. Now we encounter whether it's linear or non-linear. The only time we say it is non-linear is if we have y square or sine y or cosine y, or if we have, I don't know, e to the power y, or if I have d square y by dx square square or dy by dx whole square, like that, right? Anything that changes the graph, the only way you can change a graph is by applying a power. What I mean is, if I can have d square y by dx square, right? I can have d square y by dx square. That's still linear because I'm not changing the graph for d square y by dx square. I'm zooming in. Zooming in. So if you look at a line, you see a line. First order derivative is, so let's say if this is a line, for example, if I have a line, this will be dy by dx. This will be d square y by dx square. This section here will be d cube y by dx cube, so on and so forth, right? So on and so forth. And the higher the power you have for a derivative, higher order derivatives zooms in further and further and further. It's going to zoom in more to a point where it is precise. Cool? But it doesn't change the graph. It only zooms in. If I have d square y by dx square, now not only this is going to change, like zoom in on the graph, but this is actually not only this is not going to zoom, not only it's going to zoom in on the graph, but it's also going to change the graph. So you're going to have graph like this instead, right? So it's going to be like parabolic, something like that. So it's going to be parabolic. Cool. So you're not going to see the same graph again. You're going to see a different graph. I don't know if this is good. Yeah, now you can see better. So you won't see the same graph. In fact, you're going to see the different graph, right? So this is nonlinear. This equation, d square y by dx square minus y plus y square is equal to 0, this entire equation is what you call non-linear equation. This is what you call a non-linear equation. Now, equilibrium. Equilibrium. When is it that we consider an equation to be equilibrium? So if I have dy by dx is equal to 0, that is equilibrium. As in, there is not equilibrium, as in, we should make sure that it equals 0, but we need to find the y values from our dy by dx, in which those y values will give me the equilibrium. Meaning dy by dx is what here? Y minus 1, right? dy by dx is equal to y minus 1. So this will equal 0. So 0 would be y minus 1. So y will be 0 and y will be 1, right? So these are the 2 points that will give me the equilibrium. Now, is it increasing or is it decreasing? Only way we're going to figure that out is, since I have dy by dx is equal to y minus 1, and I also know that my 2 points are y is equal to 0, y is equal to 1, I'm going to have 3 regions. Y being less than 0, 0, y 1, and y greater than 1. So if I have y less than 0, let's consider minus 2. So minus 2 minus 3, that is 6. So that is increasing. Yes, that is increasing. So if y is equal to minus, oh, is it 1 minus y or y minus 1? Oh, 1 minus y, my fault. So it is 1 minus y. So it'll be y 1 minus y. And so I'm gonna, if I have minus 2, then I'm gonna have minus 2, 1, 2, 3. That is 3, obviously 1 plus 2. This is gonna be minus 6. The only reason plus 2 is because 1 minus minus 2. So 1 plus 2 is equal to 3. So this is decreasing. This is a negative. This is negative, so it's decreasing. Now I have 0 less than y less than 1, go for half. If I have half, half, 1/4, this is positive, right? And this is increasing. And if I have y greater than 1, so that'll be decreasing. Why decreasing? Why decreasing? Because you have a positive here and negative here. Less than 0, you have a negative here, positive here, right? So it's going to increase, decrease, increase. So you're going to have an increase, you're going to have a decrease, and you're going to have an increase. Now, implicit solution. What is implicit solution? Implicit solution. Now, when we look, okay, it's going to take time. Just give me 2 seconds. Okay, it's going to take a lot of time, and I may lose some notes. Yeah, the iPad has been not doing very well few days. So when you look at our question, the question was ln of y 1 minus y is equal to x plus c. So when I go back, ln of y 1 plus 1 minus y, so ln of y 1 minus y is equal to x plus c. The only reason we say this is an implicit solution is because y is trapped inside the function. The y is inside the ln function. So you don't write, so y is not free. Y is caged onto something. What is that something? That something is ln here. And the y is trapped under the ln function, which makes this equation implicit. Sure, this is what we call implicit solution. But something being in cage will always come out, right? That is what we call explicit. We want to move from an implicit solution to an explicit solution. Now I have what? Ln of y, 1 minus y is equal to x plus c, right? Y by 1 minus y would be e to the power x plus c. Y by 1 minus y would be e to the power x, e to the power c. E to the power c is just a constant. I'm going to have y by 1 minus y is equal to c e to the power x, and then y would be c e to the power x 1 minus y. So I'm going to have y is equal to c e to the power x minus cy e to the power x. Right? Cool? Good. This is our explicit function. Now we can do that. Y, I can take the y and the like terms and all that stuff. So y plus cy e to the power x is equal to c e to the power x. Y 1 plus c e to the power x is equal to c e to the power x. And so I'm going to have y is equal to c e to the power x 1 plus c e to the power x. Now I actually have an explicit solution. Cool. Now I have an explicit solution. Um, we have, what else do we have? We have implicit solution, we have explicit solution, we have, finding the highest order derivative, we have the linear and nonlinear. Oh, initial value problem. Y of 0 was half, right? Remember what we got the y? So here this says x is equal to 0, y is equal to half. So half will be c e to the power 0, 1 plus c e to the power 0. So that's c, 1 plus c is equal to half. And so c is equal to half plus half c. And so c minus half c is equal to half. Half c is equal to half. C is equal to 1. And so now when you go back to your equation, so when you go back to your y equation, which was ce to the power x divided by 1 plus ce to the power x. You know your c is 1, so you're going to have y is equal to e to the power x divided by 1 plus e to the power x. Right? Cool. And that's it. That is typically what everything has been explained. So far we have explained the linearity. So what type of equation it was that? So we looked at the highest order derivative. The highest order derivative was 1, meaning if I have dy by dx, that's a first order derivative, d square y by dx square second order, d cube y by dx cube third, d4y dx 4, 5, 6, whatever. And the highest order derivative depends on, like, let's say, for example, this the highest order derivative here is 1, because this is dy to the power 0, d to the power 0y divided by dx to the power 0. Something like that, something like that. And so the highest order derivative is 1. If I have d square y by dx squared, that will be second order derivative being the highest. If I have d cube y by dx cube, that will be the third order derivative, which is highest. Increase in value, the highest order derivative will change. Now you expand it. The only way we can either have a linear or a nonlinear is the only way we can have linear is if nothing changes to y or nothing changes to the or differentiation for the equation. If I have d square y by dx square, that is fine, good. But if I have d square y by dx square whole square, that is wrong. That won't make the equation linear. In fact, it's going to make it non-linear. I also have y square, that will be non-linear. That's going to change the graph. If I have sine y, that is also going to change the graph. If I have cosine of y, that is also going to change the graph. If I have e to the power y, that is also going to change the graph. Either or, if it changes the graph or if it changes the behavior of the equation, that ends up nonlinear. And we also explained what the differentiation does. It doesn't change the graph per se. What it does is that it is going to zoom in more. If I have dy by dx, it's going to zoom in once. If I have d square y by dx square, it's going to zoom in twice. If I have d cube y by dx, it's going to zoom in 3 times, and so on and so forth. Right? So nonlinear equation. Equilibrium. Equilibrium is more of like finding the critical points in which dy by dx will be 0. When will that dy by dx be 0? We need to find the two critical points that's going to give you that horizontal line, right? So we have y equals 0, y equals 1, and we also need to observe the behavior of them. Behavior of them as in what happens here. So what happens at y less than 0? What happens between y equals 0, y equals 1? What happens at y greater than 1? Because we know y equals 0, y equals 0 and y equals 1, it'll be horizontal. But horizontal. But what happens in between them? What happens on the region that is not y equals 0 and that is not y equals 1? Which means we need to find out y is equal to 0. We also need to find out what happens in between y equals 0 and y equals 1. And we also need to find out what happens at y equals 1. This will give us a better representation of how we draw the graph, which we are going to do in chapter 2. It'll give us a better representation of how we draw the graph. Because if y equals 0, so if it's negative, what happens is we're going to put the arrow downward. Down, 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 down. And if it's increasing, we're going to go up, 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 up. And if it's again decreasing, then we're going to go down, 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 down. And we're also going to find out stability and instability from there on. Cool. So we found the critical points, we found the regions, the interval points and stuff. Now, implicit and explicit solution. In implicit solution is when we see y inside a function. So ln of y, 1 minus y, that y is caged under the ln function, meaning I'm not able to do anything to that y. As of now, I'm not able to do anything to that y. Why? Because that y variable is inside the ln function. And so if I have ln of y by 1 minus y, x plus c, this is what you call an implicit solution. But you don't want an implicit solution, you want an explicit solution, because from explicit solution, we are able to find a proper function. How do we do that? So ln of y by 1 minus y is x plus c. And so I'm going to move that ln. So you have done this in calculus 1 and 2, you know the conversions and stuff. So y by 1 minus y would be e to the power x plus c. X plus c is just simply e to the power x, e to the power c. E to the power c is just a constant. So I'm just going to have y by 1 minus y is equal to c e to the power x. So y would be c e to the power x 1 minus y. And so, or I'm going to have y is equal to c y e to the power x, c e to the power x minus c y e to the power x. And so I'm going to move the y because they have the like terms in it, divide the y, and I can find the y equation. However, this will not be my equation. Reason being is because I don't have a c. Like I don't have the like the accurate value for c. That way, the only way we can actually do that is because we have an initial value problem. We have the initial value, y of 0 is half, the x is 0, y is half. Then I'm going to write half is equal to c e to the power 0 divided by 1 plus c e to the power 0. I know my c, you do the algebra and stuff like that, very easy. So you get your c value, and finally you have your y function. Cool. This marks the end of section 1.1. I'll try to do section 1.2 hopefully today or maybe tomorrow. Cool.